Okay, so but does everybody still see Paula's screen? And we'll go ahead and start the roll call, and then we go through the presentation. So I guess going through, I guess the first day would be anybody from Arkansas?
Michael Henry.
Hey, Michael.
And I'm here, Bruce.
And David. And from Florida, I see a few people. Who's on the call? Hello? Okay. Georgia, I know you're on the call, Tom.
President, yeah.
Anybody else from Georgia?
Yeah, it's William Easton in the same office as Tom.
He works for me. We don't have a freight planner still, so.
Okay. Kentucky?
Casey.
Hey, Casey. Louisiana?
Bruce, this is Laura and Dawn.
Okay.
And Kirk Zorang's here too.
Randall Withers here too.
Oh, hi, Randall.
Hey, Laura.
Okay, anybody from Mississippi?
It's Tron.
Okay. Virginia?
It's Kathy Graham.
And West Virginia? Okay. We're ready to go. We'll start. I guess we just start the discussion, and Paul, it's all yours.
Okay. All right. Great. Thanks everyone for taking out time. I know that this is a crazy busy time with everyone just trying to get things squeezed in between the holidays and doing fast lanes and everything. But this is an important step to kind of help us keep moving towards that delivery date and the training that we have set for February at the ITTS conference. So what we wanted to do today is just walk you through the methodology. You do have, we sent out yesterday the tech memo, so the presentation is really just going to follow that same flow. And so I thought it would be good to kind of walk you through the document so you'll know what to expect. And I think that that'll make the reading go a little better for you, a little easier for you, because it does get a little heavy on the technical speak and all, because this is the methodology. And then I think at the end of this, we'd like to discuss when we can expect to get comments and feedback from you guys, okay? All right, so let me try to see if this is, did you still give me control? Okay, here we go. All right, so with the overview, what we want to go through today is kind of talk about some of the data requirements, and then we'll walk through the methodology for roadway capacity projects, roadway operational projects, freight rail projects, state of repair projects, logistics cost estimation, and then integrating with economic models. Okay, so the table that you see here, this is a summary table that really at a high level summarizes the data that's going to be required. And so that's what's in the row there, the different descriptions of the data. And then across the columns, you see the different modules that are going to be available within the tool for roadway, operational and safety, freight rail, logistics, and state of good repair. And it tells you whether it's a yes or no if that data is going to be relevant to that particular module or not. And then it also lists the potential sources. So where it gives a source here, for example, the Bureau of Labor Statistics, that's going to be our default. If the user has an alternative source that they want to use, then that's fine. There'll be the capability to go in and change. But this is just to let you know where all of our default values are going to be coming for these various data requirements that we have here. Now, the one thing where it says the potential sources, where it says user, we do get to a certain degree where it's appropriate. We will talk about where the user may be able to acquire that data. Okay, but we wanted to make sure that we had kind of a one-stop shop that really gathered all of the data requirements. And then we can also make sure that this table, as we set up the tool, as we put in the different data and the actual default values, we've also put in kind of the source of those values as well, so that it will be a tool that as you go through, like for example, a lot of this data gets updated maybe annually, so you'll know where the source is to go and check and see if the default values are indeed the latest available data. Okay, so what we want to do next is just kind of, like I said, walk through the overall methodology and this will also help you better understand exactly what it is that we're proposing that the tool's going to do. We had a lot of this discussion as we were finalizing the scope and everything, and so I don't think that there should be any surprises, but it's also just a good refresher for everyone as well. So we start off with the roadway capacity projects. And so here, what we're looking at is just in the logic diagram here, we're really looking at 4 primary benefit categories, which would be the travel time savings, vehicle operating cost savings, safety benefits, and the air quality benefits. Now, you'll notice that we have a separate module for logistics cost savings, and that logistics cost savings would be another benefit category, but because of some of the different elements in calculating that, we decided to make that a separate module because it is going to require some additional user-required information. And so it may be that on some projects you're going to be able to have that information, and some projects you're not. So we wanted to make sure that this roadway capacity was a standalone and really had information that you could reasonably expect to have for every project that you're going to be analyzing. Okay, so the next step for the presentation, what we're going to do is kind of walk through each one of these benefit categories and talk about our proposed formula for actually calculating what the impacts would be. So first we'd start with travel time cost, and this is going to be the change in the travel time cost of the trip, and we'll do this by trip purpose and in each year. And so typically what you're going to do, a lot of this is going to be driven by output from your travel demand model. And so your total change in your travel time costs would be equal to your value of time times the change in the vehicle hours traveled times the average vehicle occupancy rate. And again, the P there is for the trip purpose, so we'll have auto. And for auto trips, it'll be set up so that you can look at leisure trips, commute trips, and business trips, because from an economic modeling perspective, from a benefit cost perspective, they all get valued the same, but from an economic modeling perspective, they all have different economic values as it relates to whether or not they actually represent kind of out-of-pocket cost savings or opportunity cost. And then, of course, we would also have the truck trip purpose in there as well. The value of time, obviously, is going to be different between your auto and your truck as well as the vehicle occupancy rate. Typically, we'll get these kind of measures like the vehicle occupancy rate. There'll be some assumptions within your travel demand model, and so we'll just carry those through. Okay. Another thing, too, is oftentimes whenever you're looking at these capacity projects, you're going to have a base year, and then you're going to have a future year, and kind of just an opening year of the project. And then the way in which we're setting up the tool is that you could take any 2 points in time and then calculate the stream of benefits between those 2 points in time. And so all the user would have to have is 2 years worth of data. So if you had a 2015 and a 2040, that would be enough for the model to then calculate the annual stream in between those. But it's also going to give you the capability that, for example, you may have a phased project where the first phase would open in 1 year, and then maybe 5 or 10 years later a second phase would open, and then you'd want to go out to 2040. And so we will also have the option to put in that intermediate year as well.
And Paul, this is Tom. So this is for the road projects, but interchanges, you don't do this with interchanges.
That's our next section. That's our operational project.
Okay,
so we're going to go all the way through capacity projects first.
Okay, cool.
Okay.
Just so folks understand, sometimes, because we've had this in the past where an interchange models don't do those well, so even though if it's part of a road widening and you include an interchange reconstruction to improve capacity at an interchange, it's a different animal. That's why I just want to make that point, and you're going to get to that. Thanks.
Yeah. So then the next category are the vehicle operating costs, and the model will be breaking that down into non-fuel and fuel. And so here you have your average, your annual change in non-fuel vehicle operating costs is going to be the change in your vehicle miles traveled times the non-fuel operating costs per vehicle mile. And once again, you'll do this for the different types of vehicle, whether it's a passenger or a truck, and then you'll do this on an annualized basis. Now, it may be the case that sometimes you're going to have projects where your VMT is actually going to increase, and whether that's due to induce traffic and just more trips, or, for example, for a bypass, you may have folks actually going extra mileage because it's a more time-efficient route and everything. And so, the model takes into account. So even though we may be calling some of these, benefits or impacts, they can be both negative or positive, depending upon really just the output from your travel demand model, what's going on there. Okay. For the fuel cost is actually a function of two different things. It's a function of the change in the VMT, but it's also a function of the change in the average fuel consumption, which will vary by the type of vehicle, but also by the average speed. And so we'll have the ability to be able to calculate the change in the annual fuel cost as a result of the change in the average fuel consumption, as well as the change in the vehicle miles traveled, and then we'll multiply that by the fuel cost per vehicle gallon. One of the questions that we always get whenever we're doing this is, how do you forecast the cost of fuel? Well, we're really just using the Energy Information Administration, and they'll do some long-term projections, and so that's what's being used here. So.
Is that the same if you for the vehicle fleet mix, electric versus gas?
Yes, that's the same thing too. So, some states have higher adoption rates than others, but we're typically just using just an overall national average on that. So once again, these will be the default assumptions that are in there. We will give the users, we'll make it in a platform to where the users can go in and change that if they have better, state-level information any place where we're using national averages.
Paula, this is Bruce. Is this going to be a whole bunch of linked Excel charts, or what do you see this deliverable being? I mean,
it is going to be an Excel tool. That way it'll be compatible. Everyone will be able to utilize it. It's probably going to be a couple different modules just because they start to get so big. And so, for example, the freight rail will be a separate tool. The operations will be a separate tool. And then this rail capacity will be a separate tool. And so it'll be a series of Excel spreadsheet-based tools that you'll get. So basically workbooks that will allow you to do this with a little Visual Basic programming.
Okay.
Very similar to what we demoed, to a couple of the tools that I demoed when we were going through the scoping. Okay. For the safety impacts, once again, the safety impacts, there's really a function of two potential changes. It could be you could get changes in safety costs because you have a change in the crash rate. And you could also get a change in terms of the vehicle miles traveled. So we will need to make sure that we account for both of these. So the total change in annual safety costs will be a summation of the change in the crash rate times the change in the vehicle miles traveled times the economic cost of the crash by type. And for the types, we will include just the property damage only, injury, and fatality. And I know that, Tom, when we developed tools, the economic assessment tool for GDOT, one of the functions that they had us program in, because they were really reluctant to be forecasting any fatalities or monetizing the value of any fatalities. And so we had a toggle switch where you could turn that on and off. And so that's probably something that we will carry through. We talked them into doing that because there are times when you do want to include it. For example, anytime you're doing any of the federal grant applications and everything, you do want to include the monetization of the fatality change impacts.
Yep. Cool.
Okay, so that takes us through, well, here's the air quality impact. So once again, the air quality will be the change in the annual air quality cost, and that's going to be a change in the rate of emissions for emissions type from vehicle type, as well as the change in the vehicle miles traveled. Emissions rates, they also change as a function of speed, and so that'll be used within the calculations as well. And then that'll be multiplied by the air quality cost of emissions in dollars per gram for each of the major emission types. And then once again, that'll be done. E there is representing the types of emissions, V for the vehicle type, and typically we just use a passenger or a truck. So we have two vehicle types there, and then the T being, again, the for each year over the analysis period.
Paula, this is Cheryl.
Yes.
Where are you getting this air quality cost of emissions? I don't see it in our data table. I may just be overlooking it, though.
For the emission costs, we're getting those directly from the EPA, and they would be the same ones that are in a MOVE model.
Okay, that's fine. I just didn't see it listed in Table 1.1, so I was just trying to figure out where it's coming from. Thank you.
Yeah. Okay, so those are our four major categories of impacts that the road capacity module is going to be estimating. And then, like I said, we will, at the end of this, after we run through, we'll talk about the logistics cost, which is particularly important since this is going to have a freight focus. And so we have a separate module where we would be looking at both the carrier cost as well as an inventory carrying cost, which would be added to this. But this is kind of your standard benefit categories that you would use in a benefit cost as well as in an economic impact assessment. So many of these calculations are going to be relevant across the different modules. So I just want to pause for a minute and see if there are any other questions before we go on to our next module, where we'll be talking about the operational projects.
Cheryl, so basically this air quality thing you said it's tied to moves is how, like all those data sets you've listed here early on, are all these delivered? We're going to be delivered in this first cut. On the early pages, you mentioned all of these data sets. Are they going to be delivered with the model, or are they going to be separate?
No, I mean they're going to be embedded. The data and the default values will be embedded within the tool itself, Bruce.
Yeah, because I'm looking at your table 1.1 data requirements, and I just wanted to know if you have user, FAF4, and you had something that's actually a bias estimate. But I was just curious how much of this was going to be in the deliverable and how much of this is something that the state or somebody else have to put together to run the models.
Well, I mean, where it says user, for example, construction costs, that's going to vary by project. So the user's going to have to put that.
And just for everybody, Paul, if you want to go, just so everybody knows what I'm talking about, this is the table that she had mentioned earlier. This is on number 3, slide 3. And I'm just trying to figure out which of those are going to be, which of these data sets will actually be delivered with the Excel charts, and which of these the user is going to have.
Okay, the data, I mean, we're not talking about delivering data sets themselves, but for example, the wage rates where it says Bureau of Labor Statistics, within each tool that we deliver, it will have the wage rates for the states that are appropriate embedded within the tool. And so we will have actually downloaded and created tables, lookup tables, within the tool with the necessary values that we need. The same thing for the fuel costs, the U.S. Energy information. Those are going to be within the tool. They'll be that data will be in lookup tables within the spreadsheet tool.
Okay. Okay.
And so it's not like we're delivering a whole bunch of separate databases or anything like that, but you will have the ability to go in and, look at those lookup tables to see exactly what the data are.
And so we will be able to update those lookup tables as well with...
Yes. Yeah, and Tron, that's the reason we want to make sure that you understand what the source is and everything, and then we'll even as we finalize this, we'll make sure that we put what is the year of the data that was currently being used within the tool. Because we'll be using the latest year. Like for some of it right now, we're using some 2014, we have some 2015 data. By the time we deliver it, everything should be in the 2015.
Correct. I know we mentioned earlier during the project that we needed to have the ability to actually go in there and update those factors also. Good.
Right, and because we're going to embed it as lookup tables, you just simply go in and just you'll have the ability to go in and just override and just type over to do your updates whenever you find out there's been updated data. Or for example, if Tiger or Fastlane, they issue new guidance that have updated values, you'll be able to go into your lookup table and just simply do an update of it. Okay, any other questions? Okay, all right. Now we're going to talk about the operational and safety projects. And in general, these are the types of projects that we have included within the analysis. One thing that I do want to note is that this particular analysis module will be much more sketch level than what the capacity projects are, because the capacity projects you're able to use a travel demand model, and you can go in and actually use that travel demand model and get your VHT and VMT data, and you have a lot more detail. And so the analysis is a lot more detailed than that. With the operational and safety projects, this is meant to really be used in the event that you don't have the more detailed simulation modeling, like from a VISM or a VISM model. And so what this is actually just using some general engineering standards, and it is meant for sketch level analysis. So once again, we have used this approach in Fastlane grants. We did this, Michael, for Arkansas on the I-49, and when we got our debrief with USDOT, it was actually the application from Arkansas last time that made it through all the review cycle and got sent to the desk of the secretary. So, that kind of made us feel good about the process and the fact, because it was a series of different interchanges. And even though there were some lane expansions, we did use the travel demand model, but it was really underestimating the impact that it had in terms of delay because it wasn't picking up the interchange improvements. So, Tom, this gets at the statement that you made earlier as well. And so here's just a...
Go ahead. You might pivot into this. My first caveat I see over on the right near the bottom column says continuous flow interchange. I think you mean continuous flow intersection. Sorry, I'm getting in the weeds, but that's a very precise term, continuous flow intersection. Okay. Interchange implies that it's like a system to system on a freeway, which is what I was referring to earlier. If some people have put in, Georgia's one of them that put in for Tiger money and Fastlane for these big interchange, like a system-to-system interchange. And that's what I was saying is, engineers, when you talk to them, will see that, well, we're adding capacity. We're instead of the single exit flyover lane, it's going to be, 2 lanes on it. You're adding capacity. But that folks understand, again, that's where the models are really bad. And I'm repeating, Paul, what you just said, maybe in a different way, is that if you're constructing interchange where, according to an engineer, you're adding capacity, but according to this analysis, the model, travel demand models don't see that as capacity. They're really bad at picking that up.
So for this innovative intersection, the continuous flow, is that the diverging diamond? Is that what that is, Paula?
Yeah. Just that's the most popular
Okay, I was just making sure.
Well, no, because they're not the same thing. Continuous flow intersections are literally where two streets meet, like a regular intersection. And DDIs, the diverging diamond interchanges, those are not the same. So, Paul, just make sure if you go back into that you clarify that, because they're not the same.
Okay, well, we have both. I mean, this can be both innovative intersections and innovative interchanges. And you'll see kind of in a minute. I mean, this is sketch level based analysis. If you're really going in to do some of those major interchange reconstructions, chances are that once you get to a Tiger Grant or something, you're going to have some simulation modeling done because those start to be, multi-million-dollar projects and everything. And so, a lot of times, this is when this type of analysis would be useful when you're early on. Obviously, if you've done the simulation modeling, if they have the output from that, you're going to have better data in order to be able to calculate what the change in delay is going to be.
Well, CFI is shift the left turn lane to the opposite road, right?
Yep.
Yeah.
But I think one point is that, as far as I know, there's no such thing as a continuous flow interchange. The only engineering thing they have a name for is continuous flow intersection.
Yep.
Okay, then we're just going to take that word out right here.
Yeah.
Okay.
Thank you. Sorry, but if engineers see this, and it'll help us use our correct correct word. Thanks.
Okay, and so with this, within the tool, we have some delay per vehicle assumptions built in, and this is based upon the level of service and the range of delay per vehicle. So once again, within your traffic engineering handbooks, they have a range. Within the tool, we have a default assumption, and so, but if you have an interchange justification report or simulation modeling and you know what that is, then you can always go in and override the defaults. So you can see there that for this tool, we've used kind of the lower bound in terms of the default assumption. So if you have a level of service interchange D, then it's going to assume that there's on average 35 seconds of delay per vehicle for that in your no build case. So this would be your level of service no build case here. Okay. And then you would put in what the new level of service would be for your build case, and then it's going to calculate the difference. So if you go from a D, level of service D, to a level of service B, then it's going to say that you're going to have on average about a 20-second per vehicle benefit in terms of a decrease in delay. Okay.
Paul, this is Bruce. Can you batch different scenarios at this point in the model, or you have to run them all separate?
No, the way the model is that the current version that we have, you can do up to 50 at one time.
50 scenarios?
50 different projects, not different scenarios of the same project. Well, I mean, you could do, yeah, up to 50 different projects, or you could do different scenarios of the same project.
Okay.
I hadn't thought about it like that before, Bruce, but that's certainly how you could be able to use those.
Well, this is me putting on my core hat. When everything had to be an alternative project, it'd have different alternative projects to consider to show that you presented different alternatives. So.
Right. So if you wanted to try even different types of improvements for the same solution, then you could certainly do that.
So basically you could take 2 or 3 of these and link them together in a chain. Say you're going to do an I-49 study. You could really run this through I-49 from Missouri to Louisiana, or from Kansas City to New Orleans if you picked your 9 or 10 projects.
Yeah.
Okay.
Okay, and so then what we had to do was to and again, because our goal here was to minimize the amount of user input and to minimize the amount of outside analysis that would absolutely be required. But the more generalizing assumptions that we make, we all know that that makes it more of a sketch-level planning tool. And so here what we've done is we've taken the different project types, and then we say, well, on average, what's the operational impact level on these? And so, for example, you'll have some that have a minor impact, and that's going to range from, some of it's going to be, actual increase in length of a turn bay to something as simple as prohibiting on-street parking. So you're not really doing anything, you're just changing a policy there. And so that's going to have a minor operational level impact. Well, for anything that's deemed minor, then it's assumed that the operational time reduction would be about 15%. Okay. And then you'll see that we have its categories that are deemed to be moderate type of operational improvements. And for those, you could have about a 30% reduction in operational time. And then we have the innovative intersection as a major operational impact, where you could have operational time reductions of up to 60%.
Yeah, an innovative intersection example is the continuous flow one that you just talked about. So that's the perfect place to talk about it there.
Okay, some additional assumptions that we will have built in here, and again, you will go in and be able to alter all of these. And so, as a default, the no-build level of service is an F. Obviously, you're going to be able to change that for each and every project. Your delay per vehicle, because we said that a level of F was 80 seconds or more, so the automatic default value is 80 seconds there. We also have the K factor in at 10%, and then the number of congested hours per day, because, again, it doesn't assume that you're going to get that 80 second of delay 24 hours a day along that. It's just during your number of congested hours where you're going to have that delay. And so here it's 4. And once again, that's the type of information that typically you can get from a travel demand model, or if you've done any of your feasibility studies, you're going to have some information about that. And really, if you're making a sort of improvement here, the other thought was that and again, these are still subject to change. We can change these defaults very easily if you guys have some strong opinions on that. But we figured that 4 would be the minimum number of congested hours per day in order for it to warrant an improvement. There's some concern that maybe having a default value of a no-build level of service as F might be a little aggressive, you're not going to wait till everything's an F before you do something. So that's the one that I thought that, you guys may want to think about. But again, I think that these are defaults. You have the opportunity to go in and change it, and it'll be very easy to do so. In fact, you'll have to, for every project, you'll either have to accept the defaults or change the defaults. So it will prompt you to do one or the other. And so won't be something that's in there that you forget about.
I don't see a problem with that as long as it's prompting us. I think that as long as it's asking us, is this really what you want to do, we'll know to change it. So I don't know that I care as much what the default is. That's my opinion anyway.
Okay.
Yeah, I agreed with that, because I think we do have some preferred values to use for level of service depending on where the project lies within urban or rural areas.
Okay. All right, great. Okay, so then for these types of projects, for the travel time impacts, you're going to get the change in the average annual daily travel time cost. And again, it'll be by trip purpose, because we're going to value those at different values. So it'll be the value of time for your autos and the value of time for your trucks times the average vehicle occupancy rate by trip purpose. And then that'll be multiplied by the average annual daily traffic times the K factor for the project, and then times the number of congested or peak hours per day, and then the delay per vehicle in hours. So we'll convert the seconds in the hours to get the total data. So for this, the way in which we have this module set up, the only input that the user is going to be required to put in there is going to be the average annual daily traffic, because we will also have defaults in there for your truck percentage and for your occupancy and everything, and then that can be customized based upon kind of, again, probably using your statewide averages, stuff that's coming out of your travel demand model. But because we recognize that sometimes, and because this is, kind of focusing on freight, we want to make sure that you have the capability to go in there and once again change that truck percentage, because it'll make a huge difference if your statewide average is 10% truck, but on this particular corridor and this particular interchange, you're seeing 30% truck traffic. That'll make a huge difference in terms of the overall impact of the project. And so you'll want to make sure that if you have better information than kind of your average coming out of your travel demand model, then you'll certainly want to use that.
I have a question that's going to reveal my ignorance, but you have a vehicle occupancy rate. So that would mean that you're factoring in whether there's one person or two people in the vehicle, correct?
Correct.
So is there any way to factor in, since we're a freight group, is there any way to factor in how much freight is on the truck? In other words, is a lot of freight going to see a travel time improvement, or is a small amount of freight going to see a travel time improvement?
No, that's a very good question, and that's the reason we're going to talk about the logistics module. We're really handling that logistics cost separately because we wanted to make sure that, you can run that logistics cost is going to be applicable to all of these different modules and everything. And we're going to talk about that after we get through the different types of project improvements. We'll talk about our proposal for examining those kind of wider freight impacts.
Okay, thank you.
Okay. We also know that oftentimes these operational projects bring about big safety impacts. We will allow the user, sometimes they're really not going to be about a delay. You may just have a straight up safety project. There's no congestion or anything, and so you don't expect to get value of time. So we will allow the user to go in and check and see whether it's just an operational project where you're looking at delay, whether it's just a safety project, or if it's both whenever it comes to these types of projects. And so the one thing that you'll see here is that you do have there's a little bit of difference in terms of the safety impact assumptions related to the same category of projects because they have different impacts on safety as opposed to what they might have in terms of your overall operations. So here, if it's considered to be minor in terms of the safety impact, we're assuming a 20% reduction in the crash rate. If it's a moderate, then we're assuming a 40% reduction. And then if it's a major safety impact, then we're assuming up to an 80% reduction in the crash rate.
Isn't a through lane basically capacity, and doesn't capacity increase crash rates?
Well, not necessarily, because again, if you get a lot of stop and go traffic and everything, and you get just a fender bender, so you may not be having much impact on, your fatalities, but a lot of your property damage only.
Yeah, but through lanes will reduce, say, rear ends, but they'll increase side swipes and things like that. So in other words, you reduce the crashes that have small injuries, but you increase the fatal and serious injuries with capacity.
Yeah, I mean, we can take a look at it. This was based upon, kind of the research and looking at crash rates of different types of facilities and stuff, but we can certainly, I'll make a note to take a look at that.
Yeah, because I know that that's one of the things we face here all the time is when we add additional lanes, we increase severe crashes, is what our safety group has found. So, yeah, if you just take a look at that, I'd appreciate it.
Yeah. Okay. And it may be that we just need a better description of that because we're not really talking about capacity projects here. So it could be just a better description on that one. But, no, we'll take a look at that. Anything else here pop out at anyone as being a little curious?
What is a through lane if it's not essentially capacity? Yeah, what's a better description of that?
Well, I think it's more of, I mean, we're not talking about like long distances there, so it's more of a kind of almost like an express versus a local there. So we'll certainly take a look at it and see what they had in mind. Because, we do have adding turn lanes there too, so that's kind of the... Because if you're adding turn lanes, you're kind of freeing up your through lane a little bit. So it seems like those might be more related. Okay. Okay, anything else? Okay. All right. So for the safety impacts, then the change in the average annual daily safety cost by crash type and trip purpose is then going to be a function of the change in the crash rate by crash type times the average annual daily traffic times the extent of the project influence and then times the economic cost of the crash type. So, once again, we've tried to really minimize the amount of user input data that's going to be required for this. We do have, for example, like you put in your base year AADT, and in order to get that annualized savings, we just have the average annual growth rate in AADTs, again, coming out of the shift models and the other travel demand models. And so that's how we get that annualized stream. And so it's not like you're putting that in for every year. You just put in kind of your base year that you know about, and then the tool itself will actually grow that out. Okay, so that really kind of wraps it up for the safety project. So we're really talking about looking at two major categories of impacts, and that's the travel time or the delay savings and the safety impacts. Obviously, to the extent if you have a lot of delay, you're going to have some emission impacts, and potentially the reduction in idling could also lead to some vehicle operating cost impacts. Typically, those are minimal compared to the safety and the value of time, but it's something that we could certainly look at adding into this if there was a strong desire to do so. Okay, so just something for you guys to think back and think on and maybe get back to us if you think that this is sufficient given the sketch level nature of the tool in general. Okay, so then the next module that we took a crack at is on freight rail projects. And so here we're really looking at the fact that if you have freight rail investment, that there could be overall reduced shipping costs and the savings and the economic implications of that, as well as some of the highway externalities. And so from a highway externality or your broader kind of social benefits, you could have reduced congestion and travel time savings for those highway users, avoided highway maintenance costs. There could be safety benefits as well as air quality benefits. So by and large, your safety and your air quality are going to be using the same types of formula. The biggest obstacle to get to here is to, if you're going to be having some freight rail investments, particularly anything that you're looking at trying to divert trucks to rail, then need some methodology for estimating how that's going to happen. And so we've taken a very high level, once again, sketch level approach in the event that you haven't done the more detailed analysis for the truck to rail diversion. And so here it's really about estimating the annual potential rail diversion in the study area in terms of ton miles. And that's going to be a function of the annual freight volumes and ton miles of goods in the study area, multiplied by the rail mode share nationally for each specific good, minus the rail mode share in the study area for that good. And so what we're saying here is there's just some goods that are never going to divert to rail, and so you're going to be dealing with a subset of goods that are moving within your state anyway. And so the assumption is that if you're making rail investments, that probably the maximum that you're going to be able to do, at least if you're beneath the national average, is to move you to the national average in terms of your rail share. And then that would give us an estimate that would, once we get that tonnage, then we would be able to use that to estimate using our truck conversion factors what that would be in terms of removal of trucks off from the road. Okay, so then your shipping cost impact would then be the change in your annual shipping cost. Again, doing this by goods by year would be your shipping average shipping rates per ton mile for rail minus the average shipping rates per ton mile for truck, and then multiplying that by the annual potential for rail diversion in the study area for ton miles for each of the goods. And so that truck to rail diversion will play into both the shipping cost impacts and the highway externality impacts. So that'll be kind of a first step to get that estimate. Obviously, if you already have estimates of that, then you'll be able to override that first kind of calculation with your own values.
Boy, Paul, you were busy on that one. That last one, I've never seen. You have a subscript and superscript for some of those variables. That's a lot of letters. Pretty impressive.
Good thing that the equation editors have gotten a lot better since I've done my dissertation.
Yeah. Oh my gosh.
Couldn't imagine doing this on the typewriters either.
Good grief.
And so then the next category, once we start to get into the highway externalities, would be the congestion cost impact. So the change in the annual congestion cost, and basically this is the value of time measure, would be the change in the cost of congestion per truck mile times the potential for the rail diversion times your average annual freight volumes in ton miles divided by the average truckload in ton miles. And so there you're basically just saying for all of these trucks that are taken off, then this is then what's remaining on there is getting some benefit from the reduction in congestion.
So Paula.
Yes.
The first one, it's the change in annual congestion cost in a year.
I'm sorry, I'm having a little trouble hearing you.
Is this better?
Yes, much better.
Okay. The change in annual congestion cost in a year, the first one
yes.
In that list, that's for all traffic on that. It's just on the highway, right? It's not on, you're not considering the rail at this point.
Correct. And I just, as I was talking through this, I noticed that we're focused just on the congestion costs for truck, but it's actually going to be autos that have a reduction in congestion costs as well. So we'll need to make sure we account for all traffic. So it should actually say just per vehicle mile.
Well, and that was something else I was going to ask. First of all, so you clarified this is just for the highway at this point. We're not talking about
Correct.
Congestion or no congestion on the railroad. Okay.
Correct.
And then, there's the idea that roadways fill to their capacity. So even if you take trucks off, some other car is going to find that gap and fill it. Is that accounted for in here? Is it that you're going to, even though the truck is leaving, but you're going to have maybe 2 or 3 cars in its place, or so you'll have more throughput?
Okay, it is not accounted for because in traditional benefit costs, you typically look at the change in travel efficiencies using the same truck trip or using the same trip table. And so, you don't
account that more cars will be attracted to the road since the truck's left.
Right. Now, if your travel demand model has a true 4-step component to it, and it can actually look at how traffic, it doesn't use a fixed trip table, but it's a true 4-step model, then it takes into account that induced travel.
Okay.
But if it doesn't, then there's really no way for us to do it.
Okay. So if our travel demand model takes induced travel into account, then that will be accounted for. But without that, then it is not.
But without it is not. For example, the shift model is just an OD and ME model. It's not a full 4-step model, and so it doesn't account for any potential for induced travel.
Thank you for the clarification.
Okay. The induced travel is it comes up a lot, and, models are getting, a little better at taking into account. You typically see a little more of that capability within regional models as opposed to statewide models, but you do have some statewide models that are doing it now. Okay, but you did bring up another good point, and that's the rail. So if you're diverting trucks over to rail, if you're making an investment in the rail, then what do the rail operations look like and everything? Very few states are ever going to do rail traffic simulation modeling, RTC modeling, and so, it's really hard to get that, and the railroads just aren't going to, they're not really going to provide it either. But I think so, we've chosen not to include it here just simply because it's going to be next to impossible for you to get, good credible data on it. So it's something that certainly you could do outside of the tool if you had the information on it. And so, you could certainly do that and then just add it back to whatever results the tool is giving you. So. Okay, so then keeping with the highway externalities, the state of repair impact there would be the change in the annual highway maintenance cost is going to be a function of your highway maintenance cost per truck mile. And then you'll multiply that by the potential rail diversion percentage in the study area times, once again, the annual freight volumes in ton miles divided by your average truckload in ton miles. And so basically it's your average annual maintenance cost per truck mile times the change in the number of truck miles. Okay, and then there's a note at the bottom of the slide that we also said that we'd be looking at air quality and safety impacts for this rail, and they're just going to be estimated the same way as they are for the capacity project that we walked through earlier. It's going to be both really dependent upon the changes in your VMT. It's what's going to drive both the air quality and the safety impacts under this module. Okay. Any questions or comments? So that's kind of looking at adding some of your mainline capacity for rail. We also looked at grade crossing elimination. And here, if you have a grade crossing elimination, you're going to have some travel time savings. There's the potential for travel time savings for railroads, but the real benefits typically accrue to the autos, to the roadway users. There's also vehicle operating cost savings, safety benefits, air quality, and then reduction in emergency service delay are the big categories here. And what we're doing is we're actually importing a lot of the methodology and the modules from the grade-dec. We have heard, particularly for the Tiger grants and the fast lane grants on the debriefs that we've set in on. We've used grade-dec a couple times, and they tend to like that. The feds like it when you use their tools to conduct analyses for these, and so we wanted to kind of carry that over into this tool, since we do see the federal grants as being one of the potential uses for you guys in terms of having this set of tools. So here we're looking at so the travel time impacts are estimated using grade-dec, but we also recognize that there could be vehicle operating cost savings, and so that's going to be the change in the annual fuel cost, and we'll do non-fuel as well. But again, these are very much the same way that we had talked about vehicle operating costs previously. It's the fuel consumption rate times the annual delay at the grade crossing times the fuel cost per gallon. And again, we'll do that by vehicle with the intent that we would have some defaults on the vehicle mix, once again, with the auto and then the truck percentages on that. You'd have some safety impacts as well. So the change in the annual safety cost from the grade separation is going to be the annual crash rate, and in the change in that times the economic cost of the crash. So to the extent that you're removing that interaction, you should expect to see just a change in the crash rate, and so that would be the safety benefit, more so than the change in the VMT here. Okay. One of the other upgrades that we were asked to look at from the rail perspective was upgrading the rails to 286,000 pounds. And so here, once again, the thought is that if you do that, it's going to be you're going to have more efficiency. So there's going to be more types of commodities that could potentially benefit from using the rail. So there's going to be that potential of reduced shipping cost, as well as the truck to rail diversion, which would give you again those highway externalities. With the double tracking, what we looked at here, it's the benefits of the additional track. It's kind of like with your main line, but you get reduced rail transit times because, once again, you're going to be able to run those operationally a lot better from the trains. And then you'd also have reduced rail shipping costs, because to the extent to where you're going to get some reduction in rail time and increases in services, also potentially some rate advantages. You'd be looking at the truck to rail diversion, and so that'd be shipping cost savings to the shippers that do that diversion, but then you would get your highway externalities as well. And so those would all be calculated the same as for just adding to the mainline capacity.
Paul, Tom, you say, maybe you already said it, additional rail tracks, you just said double tracking, or what about extending sidings?
Well, that's kind of what the initial one here was for.
Okay. I didn't catch it.
Whenever we looked at so whenever we worked through this truck to rail diversion, I mean that's a lot of because sidings are a way to add capacity to the system.
Okay. That's fine. It popped in my head.
Yeah.
Maybe we do the right. Maybe we do the right.
We need to add examples and make sure that we include that as one of the examples that could be evaluated using this.
There you go. Thanks.
Yeah. Okay. So the next category or the next module that we were asked to make sure that the tool was capable of looking at was the state of repair impact. And this was just driven in large part because, with money being so tight, there's a lot of states just don't have a lot of capacity projects happening, but yet they need to make the business case in many cases for just getting an increase in funding just to maintain their system. And so here we looked at the benefits of the state of good repair as being both some benefits in terms of reduced congestion, because pavement conditions can have impact on average speeds, and then also just the direct impacts of pavement conditions in terms of your overall travel time costs, your vehicle operating costs, and then the safety benefits as well. And so for this, we're building on some work that we did we actually first developed this approach for a Tiger grant that we did for the city of Jackson in Mississippi, and they ended up getting awarded the Tiger grant. And it was kind of a complete street application, but by far the biggest chunk of benefits came. It's just really horrible pavement conditions along that stretch of roadway, and so just improving the pavement conditions allow it to have a really robust benefit cost measure. And so here, there's been some research that's out there. This comes from an NCHRP study that's been done, but looking at the vehicle operating cost types, and then based upon changes in the IRI, you get impacts on both passenger vehicles and commercial vehicles. So you can look at what those impacts are. These are our underlying default assumptions with regards to the changes in pavement conditions on fuel consumptions, repair and maintenance, and then tire wear and tear. And where we typically get the IRI data for this is running, for example, using HERS. And so you have kind of your baseline HERS, and then you would have your future spending scenarios. So you'd have your current conditions, you'd have your maintenance spending scenario that you would run through HERS, and it would give you that changes in IRI. And so we're developing the spreadsheet so that it can take the output from HERS and import it in and be able to do the necessary calculations to come up with what the changes in IRI would be so that we can then do the monetization of those benefits.
Paul, has anybody used that, or have you guys ever taken that, or is this a stretch to calculate noise? Because I know when they do environmental documents on projects, they usually default do an air noise impacts, and like quieter, smoother roads are actually quieter. So if you improve them, the decibels actually drops. And you can't monetize it, but I'm just throwing that out there, not from this call maybe, but just as a little side note to see how you could get every shred of a benefit out of a project. Anyway, I'll just throw that out there.
Yeah, no, it certainly makes sense. It's not something that I've looked at or that I've included in any of these types of analyses that I've done, but it doesn't mean that there's not enough information out there somewhere to do it. So.
Okay.
Okay, and then for the travel time savings impact, there were actually a couple different studies that we looked at. One was based in Ontario. The other was for some Caltrans research. And we actually ended up adopting the Caltrans research. It is considered to be the more conservative approach. But typically doing this type of analysis, everyone thinks that you do everything to get the numbers as big as you can. And so we like to point out where we do take the opportunity to take the more conservative assumptions on this. This is also an area that we've noted for a couple of the committees at TRB for being kind of ripe for some additional research, because this is such a big topic for so many state agencies and everything that are struggling with having enough funding to maintain their system and everything. And so we do think that there's a good base level of research, and the World Bank's done a lot of research in this area and stuff, but I think doing some more specific U.S.-based research could be, very beneficial.
Does everybody know what IRI is? Or maybe everybody already does?
The International Roughness Index.
Oh, I was going to go back to your question about the IRI. You mentioned that it comes out of HERS. So, yes. I mean, in a sense, that's HERS, or is that the HPMS submission from the states?
Well, I mean, yes, but the HERS can give you the change in the IRI based upon your spending.
So you can actually set up scenarios, go back and do different budget scenarios and look at how that influenced all the projects by just changing that HERS variable.
I'm sorry, repeat that, please.
You could run HERS against this model, change your IRI, and then do a delta between scenario A over 5 projects and scenario B over the same 5 projects, simply by changing the HERS assumptions.
Yeah, I mean, you could run HERS as many times as you want it to with different spending allocations. I mean, for example, we've done this with both Georgia and Mississippi, this type of analysis as part of their long-range plan, where they were doing some trade-off analysis about different spending levels across the different facility types, whether it be on interstates or 2 lanes or 4 lanes or, those types of roads, would give you different levels of IRI across those segments, and then you could look at the economic implications of those. Okay, so for the safety impacts, it's also some of the same research that we've been using here. So the increase in IRI of 63.4 inches per mile would increase crash rates by about 25% on road segments with poor pavement condition and average travel speeds equal to or greater than 43.5 miles per hour. So this does use a combination of data from both the HPMS as well as, if you're wanting to look at what future situations is. You could always look at just what your base case is and what the economic cost of existing conditions are. But if you wanted to look at the economic impact of future investment levels, then you need to have that future run so that you know, based on different spending levels, what your future IRIs are going to be. Okay, so this is then applied to outputs of the travel characteristics, which can be generated by the travel demand model as well as information, like I said, that's coming out of your HERS and your HPMS. So then the calculation becomes the change in the crash rate is equal to the crash rate times the existing crash rate times 0.25 times the change in IRI, and then your annual crash cost would be that change in crash rate times your AADT times your average crash cost times your annualization factor. Okay, so obviously there's going to be quite a bit of behind-the-scenes processing going on within the tool, and the purpose of this walkthrough in the methodology paper is just so that you guys can understand kind of the workings of the tool, so it's not a complete black box to everyone as to what's going on and where these numbers are coming from and how they're being calculated. Okay, so that's really the state of good repair. We focus on the pavement. That's where the research has been accepted enough to where, we feel like it can give some really good, defensible, usable information within that. We have looked at bridges. I think with the bridges, that's almost to be handled. If you're adding a bridge and you're adding capacity, then that's really like a capacity project, so that would be handled under the Roadway Capacity project. If you're looking at, a posted bridge that can't handle truck traffic, then you can also analyze that through your travel demand model and then use the highway capacity model to get at that. And so that's the reason why under the state of good repair, a lot of times we think about both pavement and bridges, but for the purpose of this economic tool, we've really focused on the pavement side of things. Because most of the bridge situations that are going to have, any sort of moderate or more benefits are going to be those that will also lend themselves to being analyzed through a travel demand model, and thus just using the highway capacity module. Okay. Any questions or comments? We're getting close, guys. This is hard. This is tough any time of day, but particularly after lunch, right? Okay, so finally, the logistics cost impact. So this is what we're proposing for the logistics cost, and this might be where you want to spend, some of your time kind of thinking through and getting back to us with comments and all. But with the logistics cost, we're focused on two primary areas. One would be a change in your shipper cost, which could be a change in your in your inventory time, a change in the buffer time, and a change in the delay. It's really focusing a lot on your inventory carrying cost and the value of the freight itself, getting back to a question that was posed earlier. So if you're increasing the speed at which a driver and their value of time is a benefit, then you're also increasing the speed at which those goods are getting to their delivery. And so there could be some inventory carrying costs or the value of that freight. And then the change in the carrier cost, which again would be the change in the buffer time and the change in delay. And one of the areas that this starts to become really important in is whenever you start to see some changes in travel sheds, and it starts to get into the hours of service constraints and really limiting the number of turns that trucks can make and everything.
Paula.
Yes.
Will there it may come later, but I'm asking now. If you have a state of good repair project that improves the pavement condition, then you're less likely to damage your freight or your cargo. Is that going to be calculated in here anywhere?
You know, that's a good point because I've made that argument myself and everything. But in talking to the trucking industry, it's really hard to pinpoint that there's actually that pavement conditions can get so bad to where there's a lot of damage to goods. I mean, there's really only...
I know we addressed that. I don't think it was in our benefit cost analysis, but maybe in using some sort of rule of thumb formula in our Fast Lane grant application, because that was the purpose of our Fast Lane grant application in April, was to repair pavement condition, and so that was an important point.
Yeah. I'd be happy to look at any information that you have, but I mean, when you think about the types of commodities that are really that sensitive and everything, you're getting down to a pretty finite set of commodities.
All right, thanks.
And Laura, just from an insurance perspective, anytime there's a claim, and the first thing they do is look at how it was packaged, because anytime it's packaged and loaded, normally that's the responsibility of the shipper who put it in the truck, or the trucker himself will take liability of the cargo once it's in his truck.
Yeah, but poor roads require better packaging, which is more expensive. So,
Well, but
I'm just looking at how we can claim any benefit we can when it comes to these grant applications.
Well, I know that, but I just don't think you'll find anything on that other than using the standard, 1 or 2% return thing, and then just assume a percentage of that. So it'd be so small, it'd be just decimal dust.
All right, thanks.
Okay. But, at the same time, if you've used something in the past and it made it through the review team, we can put a rule of thumb in there if people can choose to use it or not.
I'll look it up and
okay.
let me review it again and make sure it's worth sharing, and if it is, I'll share it with you.
Okay, that sounds great. But, I've made that same argument myself. I've just never had a way to quantify it. I always kind of use eggs as the example. Okay, so what we have here is the change in the carrier cost. We're proposing that that's measured as a function of the value of time for trucks, which is usually a wage rate for truckers, times the vehicle operating cost for trucks, which is in the dollars per hour, and then that's the change in the annual buffer time. And so that's really kind of their planning time that they have there. So we've done quite a bit of work where we've had the opportunity and the luxury of doing a lot of on-the-ground interviews, particularly in the Norfolk area, for example, up and down the 95 corridor, in the Memphis area. We've done a lot of research where we've actually talked to shippers and everything, and we've gained a lot of information about particularly drayage operations and travel sheds, and then how much time, buffer time, do they currently have. And so we've been doing some research to use our kind of expert knowledge that we've been getting from the ground and ground observations and combining that with some of the performance measurement data from federal highways to see if we can't come up with some linkages between that and basically be able to use the buffer time indices as calculated using the National Performance Measure database, and then using that to associate with the potential impact that it would have on truck travel sheds and truck turn times. And then from that, we would be able to take a look at how that really impacts carriers' costs. And so we're trying to make this a little better than sketch level, based upon all the knowledge that we've gained through the various different studies that we've done over the years and everything. So this is still the piece that is most work in progress, because some of your other models that are out there, they may give you a logistics cost savings, but they're basically just taking the value of the tonnage of freight and then multiplying that by the time savings and everything. And if you talk to the industry, that's probably an overestimation of what they're really getting at is the inventory carrying cost by doing that, and we can certainly do that. But the bigger piece of the pie, when you talk to the freight stakeholders, is really because they're under the constraint of the hours of service. So anything that changes travel times and everything has the potential to impact how they actually operate. And if they are doing 5 turns a day, but they only have a buffer time of about 30 or 40 minutes within the whole day to complete all 5 of those turns, if you increase each trip by 5 minutes, then you're going to lose that last turn, and that's that's a loss of revenue right there. That's more than just that 25 minutes times their hourly rate. So that's what we're really trying to get at here, and we're still piecing together some of the research and trying to make sure that we're comfortable enough with those correlations and everything that we're coming up with. Here's the change in the inventory carrying cost, which I just kind of talked you through there. And so this is the hourly rate charged for the inventory, and a lot of times models just substitute the value of the freight itself in that as the carrying cost, and then multiply that by the value of the time-sensitive inventory that's being shipped via truck. And then look at that by the change in the inventory time, and then that would be again just your time savings that you're getting from the improvement. And so those are our 2 elements of the logistics cost, and I think that given the focus of this, everything else is really built upon previous stuff that we've done that's been, incorporated in at different state level analyses and the and the feds and everything. And so this is the piece that I think is just a little newer and a little different way of looking at it and bringing in some additional data and information to bear on it. Okay. Any comments?
Tom, so this is my list.
I'm sorry?
This is Tom. So you're done? You're ready for us to kind of babble? You ready to go?
Ready to battle?
Ready for me to babble?
Oh, babble. I thought you battle. I'm like, oh.
Battle. Oh.
No, please, go ahead.
You hit, actually, some of it you already hit, because my question to myself was, hey, some of this, you could reference some other winning Tiger or Fast Lane grant applications to see if somebody had some great idea that we didn't do in our methodology here. But it sounds like you've done that, maybe?
Well, I mean, certainly we've gone through the processes where we've been involved, and then just the comments. We've had the opportunity to sit in on debriefs on various rounds, and so we've taken notes and everything from those debriefs, and that's certainly incorporated what we've learned from those into what we've talked about today. and into the programming of the tool. But we've only been involved in a fraction of those, so it could be that some of you all may have other examples of things that So certainly anything else that you would think that we should consider or at least think about, then be happy to do so.
The second thing is, which I think you already hit on. I wrote a little note saying it'd be great to have just like a textbook, a little example, just like a little call-out box with an example problem with a hypothetical situation, which I think I heard you say as an idea, right?
Yeah. So along with this, the report that got sent out yesterday was just the methodology. So we will finalize that, and that'll be the technical memo. But also with the tool, we'll do a very detailed step-by-step user guide for the tool that will have actual screenshots, and then actually be able to provide you with some sample data and everything to go through and actually run the tool and make sure that you're understanding all the different steps and everything. And then there'll be some key spaces. Obviously, the tool's not going to take away the need for some working knowledge of transportation planning and benefit cost analysis, but certainly there'll be some places in the tool where we'll be able to put in some QA/QC checks, like for example, if you get a benefit cost ratio that seems really high, then we'll red flag it. We're not going to tell you that it's absolutely wrong, but we're going to say this is kind of outside of normal range. Make sure you check a few things.
Okay. And my last one that you heard me hit on it a couple times. I'm going to beat the dead horse into the ground here. A little background. About this time of year, matter of fact, I think I have no proof of this, but I imagine it'll be hitting the streets soon. ATRI always puts out their kind of top 100 bottlenecks in the country. And matter of fact, I talked to Jeff Short he asked me a question like last week and didn't say anything about cryptically. Thought, it's about that time of year, to see where we all fall out on it. And those are all interchanges, which is, for some places freight bottlenecks are you need to widen the freeway or the road. But a lot of bottlenecks are literally points on the map that are interchanges, and ATRI comes at several states, including me, with the question, what are you going to do about your location, your problem children that made our list? So as part of this, you're giving make sure we give a lot of discussion, a lot of details on doing this for interchanges. I already hit on it, but now you guys kind of know why I was really, really poking at that, because they're hard to do. They're kind of tricky, and they're special. They're their own special thing. And I've had people say, get the outputs from the travel time model. I'm like, that's the wrong tool. It does, just like you said before, and I said already. It's when we did it years ago with the freight plan that I've got. We did benefit cost and return on investment. I remember we had to kind of go off model and had to kind of back of an envelope almost.
Well, and that's really
I
what
remember
we have.
that, and especially again, I'm almost done. But the fact that these, I was looking at the list from last year for 2015. Of course, Atlanta was number one, and we probably won't be next year. But there's an interchange in St. Louis. There's one in Louisville. There's one in Baton Rouge, and they're all in that top list. It's not a good list to be on, so I'm just throwing it out there just to be able to have something for us, all of us listeners, especially if we have a problem child on this list, and these spots on a map are the big ones that the trucking industry comes to the governor with. What you guys do as part of this tool is really going to have to be like a home run. So I'm done. Thanks.
Well, I just want to restate that the tool is not going to be able to replace the need for VISTA modeling on some of this. So it's very, when we went through that section, it is very sketch level. So. Okay. Anything else in terms of the direct or the indirect impacts, or the types of projects or anything that we've gone through? Okay, so the next thing is just really about translating these impacts into the economic model inputs. And so this is also something that we're going to be automating as part of this tool. There's still a handful of you guys that I need to talk with. I think I have the information from most of you, but we do need to touch base, and we really need to know in terms of your travel demand model, your statewide travel demand model, and your economic model. If you already are prescribing to something, we need to know what that is so that we can, because we will be, for your statewide travel demand models, we're actually going to be developing scripts that will automatically process the output of your travel demand model into the input that's going to be necessary to run the tool for any of your roadway capacity projects, so that will, again, make it integrate seamlessly and take out one of the steps that an analyst might have to do. The other part of it at the tail end, once it goes through calculating all of these impacts, we then have to prepare those monetized values of travel time savings, vehicle operating costs, safety. We have to prepare all of those for input into the economic model in order to estimate the impact in terms of jobs, GDP, and income. And the way in which we do that, we'll be developing some macros to develop the input files, but we need to know from each state, what economic model you're using and at what level of geography is that model. So if we have not already had that interview with you, then please do reach out and let's try to find a time to talk, certainly over the next couple weeks before the Christmas break, so that we can, we'll be getting our guys started on doing the scripts and everything in January, so they'll actually have to get your model files from you in order to do that, and then we'll also have to be developing the spreadsheet tools. Now, what's probably going to happen, because each state's going to have different elements, we're probably, instead of just delivering one suite of tools, we're probably going to deliver each state a state-specific suite, and then Bruce, you'll kind of get one that's a little more generic, okay? That'll have like. Oh,
I don't get the love.
Well, I mean, you'll get all of them.
I'm just joking.
Obviously, all the states can have access to all of them, but I figure that we were running into the problem of trying to put like all of the state's county average wage rates into a single. The spreadsheet, it was just, they were getting too big and cumbersome, and they were starting to crash, and so it's easier to keep it in Excel if we can kind of keep these as separate.
Well, Paula, we can have a separate discussion about ODBC drivers and that, which might mitigate some of those things.
Okay. So anyway, for translating the impact into the economic model, regardless of whether you're using an M-plan or REMI model, your input variables, we're going to have our time cost factors, our vehicle cost factors, the travel demand factors, and then the business factors. And then from that, we'll be looking at the travel cost by cost type, whether it's passenger time, crew time, freight time, reliability, vehicle operator cost. And then we have to actually decide, which of these costs actually represent out-of-pocket. Is it the household time? Is it household out-of-pocket, the vehicle operator, the industry, the non-freight? And so we have to allocate those travel costs by the user type. And then from that, depending upon the user type, then that's going to dictate how we map those changes in travel costs to your different industry sectors. And so that then starts to become the basis for the input into your economic model. And the way in which that needs to be organized in the policy variables that it's going to impact depends upon which model that you have. And so then we'll generate a macro that will then automatically, once you run the macro, it's going to produce the input file to where you can open up your REMI model, or you can open up your M-plan model and just hit the import button and import that file and hit run, and then you'll be able to run it. And then once you run your model, it's your economic model itself that will give you the total impacts, which will be, again, expressed in terms of employment, gross state product, and then income. And then within the tool, we'll have it to where you could import that data back in, and it will generate both your benefit cost ratio, We also have toggle switches on there for a 3% and a 7% discount rate so that you can be compatible with what's required with the federal grant. And then even though not required, it is, we typically also include our economic impact results within those grant applications as well. Okay, so that's really what I wanted to kind of walk through with everyone today so that they could get a sense of where we are in the process. A lot of the programming has occurred already. We're still in the data gathering stage for some of it, and particularly, as I had mentioned, the logistics cost is the one that we still are doing, actually still doing some of the original research on.
Paula, just before everybody starts jumping off the line, I have recorded this session. I will put the audio up on the website with Paula's PowerPoint, and I will also post the methodology paper. And then I'll talk to the peer group, the committee, and see how they want to proceed regarding timelines. But so, Paula, what states specifically have not talked to you?
Let's see, Kentucky, we had to reschedule. There was some confusion on the time. Florida, Georgia, and I think, Cheryl, I don't think we've had a chance to connect either, so Missouri.
No, we haven't.
Paula, who did you talk to at Louisiana?
Oh, no, that's the other one.
Oh.
If you could send me a list of who you interviewed, Paula, just so we can have that, and so we can nag them. I mean, encourage them to participate.
So you want a list of who we still need?
I'd like to know who you talked to, and then who you have not talked to.
Okay.
I know we've shamed Tom because you said you hadn't talked to Georgia, and y'all are so far away.
Well, but he told me he wanted to wait till he got his new freight planner on board.
Oh, okay.
Yeah, which didn't happen, so.
But the thing about it is I know everything I need to know from Tom. The two big questions. Yeah. So.
Okay. But I just want to let everybody know that I will be posting these online. And one of the things is if people want to get back to this, Paula, we're trying to get feedback, and we definitely want to get feedback from all the states, before Christmas, because then, we don't want middle of January, we need to look at it like this. I think it'd be really too late for a February training session, so.
Yeah, absolutely, because, January was when we're going to be really finishing up all of our programming and all of our data and stuff, and so.
Well, and it could be two. It could be two, Paula, that maybe in January we could have a pre-FEAT meeting at TRB. I know that I will be there. I think Tom will be there. We just maybe go aside for an hour or two and just talk through it and see where it's at.
So for the benefit of people who are on the committee, just everybody at large, the next couple milestones, could you go through those again? You'll be reaching out to the states for their models, right?
Oh, you mean for me? Yes. So for their statewide travel demand model, and also their preference on their economic model. If they already have one, then we need to know which one. And if it's in-plan, more than likely you're at the county level. If it's REMI, then it's anyone's guess. So we need to get your regional composition.
So
in Mississippi, I have your REMI model. Georgia, I have yours, so we're good to go. Arkansas, I have your in-plan model. Eric, I did talk with him. He said he still had to get back with me because he wasn't sure if they had anything. And if you don't currently have an economic model, do you have a preference of what that might be?
Okay. Well, Paula, I'm going to set up a conference call for the states, the peer review group maybe next Friday or something like that, just so we can have a final powwow about it.
Okay.
Okay. And if anybody has any other comments, I know, like Paula said, a lot of this is something that you're going to have to digest and chew and digest and chew. So, bon appetit. And I'll talk to all y'all later. Thank you, Paula, for taking the time to walk through this with us. And and I will post this and send out a link to everybody.
Okay, great. Well, thank all of you guys. So I know this isn't the most fun thing to walk through. So.
Oh, it's been glorious. What do you mean most fun thing? The highlight of my day.
Paula.
From one economist to another, right?